Okay, given that the first derivative is equal to this, what's one possible equation for fx? Okay, this is kind of funny that this is in the chapter 14-15 review packet, because back then we didn't know how to integrate, but now we do. So we're going to solve this by integrating. So we're going to do the antiderivative. Okay, so the antiderivative, I add 1 to the exponent, multiplied by the reciprocal of that exponent, and times by whatever constant I already had. So this is going to be my f of x that I'm trying to find. And then the next one, I'm going to add 1 to the exponent, multiply by the reciprocal, and multiply by whatever constant was already there, plus 7, I'm going to give it an x. So if we simplify that, 4 goes into 25, so I get 5x to the 4th, 3 goes into 6 2, so minus 2x to the 3rd, plus 7x, and then we know we have to do a plus c. Why is there more than one possibility? Because when we take the derivative of a constant, the derivative of a constant is just 0, so it goes away. So we do not know what the vertical translation is. So the graph could move anywhere up or down and still have the same derivative. Okay, so vertical shift could be anything. Vertical shift could be anything. Because the derivative of a constant is always 0. So if the vertical shift was 2, the derivative of 2 is 0. If the vertical shift had been 10, the derivative of 10 is also 0. So we have no way of knowing, unless we're given a point on the original function, we have no way of knowing what the vertical shift was. All right, evaluate the limits, justify your answers. All right, if I put in a really, really big number for x, these two things right here are going to become insignificant, so I can just ignore them. And then x squared and x squared, those end up just reducing out. X squared divided by x squared, those are the same number, so that's just 1. So I'm left with 12 over 3, which equals 3. So as x goes to infinity, it approaches 3. So one thing that would be interesting would be to put this into the calculator just to verify our answer, so we can prove to ourselves that we believe what just happened. So I'm going to go ahead and put it in. 12x squared minus 3x divided by 4x squared plus 5. If I graph it, we should see that we have a horizontal asymptote at y equals 3, and sure enough, we do. See how it doesn't go any higher? So we could mess around and look off to the right and see what happens out there, but you can tell that it's just approaching some number. What number is it approaching? You can do, let's put in the value. I don't think it'll show us if I do this because my window's not big enough. Wait. Let's do that again. So instead of 100, let's put in 8. And see how it says 2.85, so it's approaching 3. So if I were to zoom out, now I can put in a bigger number for x. You can't put in a value that you can't see on the graphics calculator, which is unfortunate. Okay, so let's say I put in 20. I should be even closer to 3. See, I'm 2.95. All right, so anyway, I hope that convinces you. The answer is 3. All right, next one. Letter B. Okay, notice here if I put in a really big negative number, what's going to happen? These are going to become insignificant. So I'm going to be left with 5x to the 3rd over 3x squared. Okay, these x's go away. 2 of them do. I can reduce that. And then if x is really, really big, these numbers are going to, this number is going to become really insignificant. And so then what are we left with? We're just left with negative infinity. 5 times negative infinity is still negative infinity. So when we put in negative infinity, it's still going to be negative infinity. Okay. And if we go over here, what happens when we put in positive infinity. So if I do 5e to the negative, change my x to infinity, plus 9. Now let's rewrite that negative exponent as a positive exponent. So I have 5 over e to the positive infinity plus 9. Okay, 5 divided by e to positive infinity is a huge number, really, 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 really big. So if you take 5 and divide it by an enormous number, this basically just becomes 0. So I'm left with 0 plus 9. So therefore, my limit is 9, because this part is going to become 0. But I still have the plus 9. So my answer is 9. All right, the limit as x approaches 3. Well, this one's kind of a stupid one, because we can just plug it in and get the answer. So it's kind of like, why do you have to ask this in the form of the limit? Why not? Okay, 3 squared is 9. 9 times 4 is 45. Minus 6 plus 1, so that would be 40. Okay, next one, limit as x goes to 0. Notice if I put in 0, I'm going to have an undefined function. So there's going to be a hole in this graph. But we can figure out what it's approaching by factorizing and reducing. So on top, they both have an x in common, so 3x plus 8 over 4x. Now I can reduce out those x's, and I'm left with 3x plus 8 over 4. Now if I plug in 0, 3 times 0 plus 8 over 4, I'm left with 8 over 4, which is equal to 2. So that one has a limit of 2. And this one, same thing, I can factorize it. So I get x plus 6 and x plus 2. 6 times 2 is 12, 6 plus 2 is 8. And I have a difference of squares here on the bottom, x plus 2, x minus 2. The x plus 2's go away, and so now I can plug in my negative 2. See, I couldn't plug in negative 2 straight away because negative 2 squared is 4, and 4 minus 4 is 0. And you can't divide by 0. That's why I'm doing this. Okay, so now I'm going to plug in negative 2. So negative 2 plus 6. And on the bottom, negative 2 minus 2. So I get 4 over negative 4. What does it approach? Negative 1. There it is. All right, this one, we don't talk about continuity in this course. Leave that to HL. Differentiate this from first principles. So our first principles formula is the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. And you know what? Is this in the formula packet? I don't even know. And I don't have a formula packet hanging around here. It probably is. That formula is probably in the formula packet. It's got to be. So now we're going to plug in x plus h right here. So we're going to get 4 times x plus h minus 3. So I just did that part. Minus f of x. Okay, this is my f of x plus h, and now I'm going to plug in my f of x, which is 4x minus 3, all divided by h. I'm going to simplify this, distribute, I get 4x plus 4h minus 3, distribute this negative, minus 4x plus 3, all divided by h. I can simplify this, the minus 3 and the plus 3 cancels out, and I'm left with, oh, the 4x and the minus 4x cancels out. I'm left with 4h over h. The h's reduce out. I'm left with 4. So the derivative of 4x minus 3, we already know, is 4, and now we've shown it by using first principles. Okay, next one. Oh, that was the end of the page. Stop the video.